Before you ever attack an identity, always get your sheet of identities handy and see if it looks familiar to anything. The key identities that you always want to keep in mind are this one, but these are just variations of this one. These ones definitely, especially this one. These you'll know when to use. The question will be about addition or whatever. There's usually a few more double angles. And you should always say, well, do I see anything here that's similar down here? Well, I see secant here, but I don't see any squares. Cosecant squared. So probably I'm just going to use some basics. Now I'm going to assume your teacher wants you to work the left side and the right side independently, but the truth is you don't have to. My best bet here is not to use the words tan and secant, but tan is the same as sine x over cos x. And secant, remember I have a plus here though, is the same as 1 over cos x. Okay? We quickly see that they have the same denominator. So I don't have to adjust at all. I can just put them all both like this, like that. Good so far. Now, I mean, technically I should, and then we'll just keep this on the left. Technically, I should be multiplying by 1 minus sine x on both sides to get my solution. I mean, if you want, let's just multiply both sides by it. Still working left and right. Okay. Over here, it's clear it's canceled. So my goal here is to get to cos x. When I distribute it in here, I get 1 sine x plus 1 minus sine x squared minus sine x. So let's do this. Let's distribute it. We get sine x plus 1 minus sine x squared. I put the square here so you don't think it's x squared. Minus sine x. Well, I can see I have plus sine x. This should be minus sine x. It's clear I can see sine x plus sine x here. Minus sine x there. So I'm left with this. And this is over cos x. This is how I would solve it anyway. Then I would multiply both sides by cos x to get rid of the denominator. It goes away here and becomes cos squared x. And this matches one of the identities right here. If I rearrange this to get cos x squared on the one side, it's equivalent to 1 minus sine squared. So this is essentially your truth page. These are all proven true. You're trying to get something that you're not sure is true to match. Now, I don't know if your teacher's saying that you can't use left and right, that you've got to keep it all on the right. Some teachers do that, and it's kind of weird to me. But I mean, I could always do the same thing, right? I could always say, okay, well, it's still sine x plus 1 over cos x. I wanted. And I could still say, okay, well, let's see what I can do here. Well, I bet you I could convert. Yeah. Let's see if I can convert all of this to that. Okay. So sine x, if tan is equal to sine x over cos x, then sine x is equal to tan times cos x. So let's see if I can do anything with that. Like that. So far, nothing. Let's see if I can get it up top. So if I multiply this by the bottom, no, I don't think that's going to work. Let's try something slightly different. See if I can convert this by multiplying it top and bottom by the same thing. And I multiply it by the opposite. 1 plus sine x, like that. So this is multiplying it by the opposite. So that I'm going to get 1 plus sine x minus sine squared. Okay. This is essentially multiplying it by 1 plus sine x. So it becomes 1 minus sine squared down there. Up top, it becomes cos x plus cos sine x. I distribute it through. Okay, so far, so good. 1 minus sine x squared has an equivalent over here. It's cos squared. When I have something over the same fraction that's added at the top, I can put this over this plus this over this. Here it's quite clear that one of the coses cancels and I'm left with 1 over cos x. Here it's clear that one of the coses cancels and I'm left with sine over cos x. So I'm with 1 over cos x over sine x over cos x. 1 over cos x is secant x. Sine x over cos x is tan x. So left side is equal to right side. A little bit more convoluted. I don't like it. Takes a little bit more technique and finesse. I could have done the same thing and inverted this until I got to that as well. And again, it just becomes a little bit complex. So for this one, I think I would multiply both sides by cos squared. No, just by cos over cos. And then I could convert that to 1 minus sine squared. So I could do the reverse on this side, but I don't like as much as working with you. So you have to ask your teacher if they want you to do this method, where you keep everything on the right side and the left side, or if you're allowed to cross multiply.